Okay, so thus far in our study of the sine and cosine graphs, we've looked at the base graph, we've looked at the amplitudes, and we've looked at the periods. In this video, we're going to talk about the displacement. Our objective: determine the displacement, also called the phase shift, of a given sine or cosine function. Well, let's first define what the word displacement means. Displacement means how far a function is shifted horizontally. And here's an example I found on the internet. If we look at this function that has the dashed line starting at the origin, this is the sine function up to here. From here to here is 1 period, 2 pi. And you'll notice that we took this solid line function and it has been shifted from here to here, okay, and that's called the phase shift. Now it starts here and it goes that way. And generally we kind of look for the origin, so we can say that this one here has a phase shift. I'll talk about it kind of being in this direction, but of course you could talk about it in the other direction as well. All right, so the base sine, y equals the sine of x, and cosine, y equals cosine of x. These base functions have a displacement of 0. Starting here at the y-axis, they don't have any displacement. And let's take a look at this. So up until this point, we've graphed the sine and cosine functions starting at the y-axis. Well, as you can see here, displacement or phase shift is going to change the starting point, moving it to the right or to the left. So it's going to be starting off of the y-axis. Okay, let's take a look at our base function and how we come up with the phase shift. So here, from 1 to -1, and we'll go out to 2 pi, which means that's pi. So here's a rapid sketch of the sine function. Okay, and the way we'll show, so here's the base sine function. If we write the formula, or we write the equation as sine of x plus 0, so this adding something to the x term or subtracting something from the x term, it's going to play a role in our displacement. Okay, so obviously you add 0 to it and nothing has changed. Similarly, if I can say it, if we look at our base cosine function again from 1 to -1, and here is 2 pi and here is pi, and our cosine function, whoops, I think I got a little ahead of myself here with drawing it. Our cosine function goes down like this, our base function. And there's our cosine function, and it has no displacement. And again, we can write the cosine function with 0 displacement as the cosine of x plus 0, the base cosine function with 0 displacement. So we're going to be changing this time what is being added to the x term within the function before the function is calculated. Okay, as we've seen with amplitude and period, the displacement can vary. Okay, in other words, the function can shift left and right. As you'd expect, this also affects the location of the 5 key points. All right, let's do some examples, and give me a second to get my act together here on this end. Okay, example number 1. Sketch the graph of y equals the sine of 2x, and here is that displacement piece, so we'll see how it's calculated, plus pi over 2. Okay, so let's first talk about it looks like the amplitude is 1. We won't worry about that. But the period is equal to 2 pi over b, which in this case is 2 pi, b is 2, it's the x coefficient, over 2. So the period is pi. We're going to have one full period take place within a distance of pi units. And we know the period divided by 4, which is pi over 4, this is the distance between the key points. Okay, so let's take a look at this. We're going to go, so period is pi. We have pi over 4 between, so we'll start at 0. And we'll go to pi over 4, that's our next key point. Then we'll go to 2 pi over 4, which is pi over 2. And then 3 pi over 4, and then 4 pi over 4 is pi. Now let's take a look at this base function, which is the sine of 2x. If I put in 0 into this function, and I use my calculator in radian mode, the value is 0. If I put in pi over 4, out comes 1. If I put pi over 2 in here, this is the sine of pi, which is 0. If I put in 3 pi over 4, I get negative 1. If I put in pi, I'm back to 0. So let's graph the sine of 2x. Let's graph this function here. So give me a moment to... Well, first off, I'm going to go from 1 to negative 1, so I'll do that here. There's a negative 1 and there's a 1, because the amplitude is 1. And I'm going to go from 0 to pi. So pi over 4, pi over 2, 3 pi over 4, pi. So here are my key points, 1, 2, 3, 4, 5, for this function. And again, this is pi over 4, this is pi over 2, this is 3 pi over 4, and this is pi. And we know we adjusted the period. So here is that function. I'm going to do it in a dash. And so here comes the sine of 2x. And I'll just keep going so that I can write y equals the sine of 2x. Okay, now we're going to see what happens to this base function. This function, the sine of 2x, when we put on this extra pi over 2. Okay, so if we add pi over 2 to it, when 0 goes in, what's the value coming out of this? Well, it's 1. When we put pi over 4 into this function and we do the math, out comes 0. When we put pi over 2 into this function, we do the math, out comes negative 1. We put 3 pi over 4 into this function, do the math, 0. And then this is 1 by putting pi in there. And you can see what's happened here is this function has shifted. Okay, it has shifted. We've added pi over 2 and it resulted with a shift to the left. Okay, let's do it. So 0 has us at 1. Pi over 4, so here it is. Pi over 2 is negative 1. So here becomes, and I'll just continue on a little bit further. And this is the function y equals the sine of 2x plus, plus pi over 2. Okay? So you can see here, all right, from the base function, okay, and if I continue going down here, you can see the starting point shifted. Let's see if I can come up with it right. There we go. Everything shifted to the left by pi over, to the left by pi over 2 units. Okay, excuse me, pi over 4 units, excuse me. Okay, so we have we added pi over 2. Okay, adding pi over 2 shifted the graph left. and it shifted the graph left pi over 4 units. Okay, from here pi over 2 to pi over 4 is pi over 4. This is pi over 4, this is pi over 4, etc. Okay, now let's talk about what that means with displacement. Okay, a shift to the left by pi over 4 units is equal to saying it has a displacement of negative pi over 4. The negative means, of course, we're shifting in the negative direction. We're shifting left. Okay, that negative sign. So shift left pi over 4, or a displacement of negative pi over 4, which means it shifted left. Okay, now we'll get next piece in a second. So there you have it. Let's take a look at this in Desmos and we'll see it. So let's pull out our graphing calculator, and let me get myself signed in. Perhaps there. Whoops, I just had it. Okay, so here's our graphing calculator, and now let's put in our base function without the shift. Which number 1 here, y is equal to the sine of 2x. Okay, close parenthesis. That was the function without the shift. Okay, and you can see here it started at 0, 0, and so we went from 0, 0 up here is pi over 4, 1. We saw that. Then pi over 2, 0, and then 3 pi over 4, negative 1, and there's the pi period right there. So 1 period took place in pi. Okay, then we said, all right, let's do an adding of pi over 2 within the sine function. So we have the sine of 2x plus, if I can press the plus key, and then I have a pi over 2. And there it is. Okay, so the blue one is the shift. Now take a look here again. The starting point was here. It shifted to the left right there, pi over 4 units. There's the pi over 4 shift. And then everything went to the left. Okay, and again, 1 full period. Well, from negative pi over 4 to 3 pi over 4, that's a pi distance here. Okay, this one minus this one gives you a distance of pi. So we can see the shift left right there, and then of course all of the corresponding points we can tap and see them on the shifted graph of that sine of 2x function. Okay, let's do another example, and then we'll kind of we'll do a general how things are working. Okay, so what we need to notice here, let's remind ourselves, we had a shift. We added pi over 2, we had a shift left of pi over 4. So this is obviously, there's more to it than just this plus pi over 2, because the shift was pi over 4. There's a bit more to it than just that piece at the end there. Let's take a look at another example. This is the cosine function. Y equals the cosine of x minus pi over 2. Well, let's not graph that. Let's graph the cosine function. And so I will again go from, I have no amplitude. Whoops, this is going to go from 1 to negative 1. And the cosine function, let's see here, pi over 2, pi, 3 pi over 2, 2 pi. Okay, so here's pi over 2, pi, 3 pi over 2, and 2 pi. There's no b, so the period is not being affected. And so I will again draw a dashed line to indicate the function without the extra piece being added or subtracted. So this is the y equals the cosine of x, without this minus square root of 2 in it. Okay, so now, let's remind ourselves the period is equal to 2 pi over b, which equals 2 pi over 1, which equals 2 pi. That's what I came up with. And the period divided by 4 is the distance between the key points. 2 pi divided by 4 equals pi over 2. We already knew that. Okay, so we'll start at 0. And we'll go every pi over 2. So pi over 2, pi, 3 pi over 2, and 2 pi. Now we're going to shift it. Okay, so what happens? I'm going to put 0 in for here, and the cosine of negative pi over 2 is also 0. I'll put pi over 2 in here. Pi over 2 minus pi over 2 is 0. The cosine of 0 is 1. I'll put in pi, do the same thing. I'll get 0. I'll put in 3 pi over 2, and then I'll displace it with this, negative 1, and then I'll put in 2 pi, and I come out to 0. So this function is here. Okay? So now let's graph it. At 0 we have 0. At pi over 2 we have 1. And then we notice we have this. And yes, it's the sine function, a little different way of writing the sine function because it's exactly like it. But here is, this is y equals the cosine of x minus pi over 2. You'll notice here, okay, we normally start the cosine from here, so this shifted to the right. Everything shifted to the right with this one, okay? This was the base function here. It went to the right to start here, and then everything went to the right. So subtracting pi over 2 shifted the graph to the right. Okay, shifted the graph to the right, pi over 2 units. Well, that's interesting. I have a pi over 2 here, and I got pi over 2 units here, but when I had come down to here and show you, when I had a pi over 2 here, I got pi over 4 here for some reason. And you can guess that the b plays a role in that shift because the b here is 2, and down here, the b here is 1. We'll see that in just a moment. Okay, like up here, a shift to the right is going to be a displacement of positive. So a shift to the right, which is what we had here, equals a displacement. Whoops, a shift to the right. Let me erase that. I might get my phone to stop wiggling. A shift to the right I've said by above. Let's keep my wording the same. By pi over 2 equals a displacement of positive pi over 2. The positive sign tells us we are displacing pi over 2 to the right. If you just say it's a displacement of positive pi over 2, that means you're going to the right pi over 2, which is what we did here. Okay? Okay, so there we have it. Now, let's wrap this up. What have we learned here? And I'll tell you how to calculate the the displacement, the phase shift. Notice, number 1, the displacement is affected by adding or subtracting from the independent variable. That's what we did before the value of the function, sine or cosine, is found. Okay, when we added a number, we shifted the graph to the left, and that took place in example 1. When we subtracted a number, that shifted or displaced the graph to the right, and that took place in example 2. Okay, so now, given y equals sine of bx plus c and y equals cosine of bx plus c, we notice that the b might play a role in this. Here is how to calculate the amount of displacement and the direction. We take the opposite of c over b. Okay? Displacement changes where both the sine and cosine graphs start. So we'll think about where it starts, and thus it changes where they intersect the y-axis. So we've now changed the horizontal, which means we are intersecting the y-axis at a different place. Okay? Let's put it together. We can now expand our sine and cosine functions to y is equal to a times the sine of bx plus c, and y is equal to a times the cosine of bx plus c. The amplitude is the absolute value of a. As a reminder, if a is negative, then we invert the graph. The period is 2 pi over b. And the displacement is the opposite, or the negative, of c over b to come up with how far you're going to shift it. Okay, in the next video, we'll take a look at a couple of examples and how to get these things started and graphed.